Okay, so I've got the carb caps here that I'm getting ready to. I'm gonna remove these old buttons here, and we are going to install some new ones. So we got to do a little bit of machining here, and we'll see how all this goes. I've got my Bridgeport milling machine here all set up. This end mill is approximately 1 inch in diameter, and that's plenty enough to be able to take this button here out. I've got a fixture here that we made. We got this counter bore cut here, and that fits onto this diameter quite nicely. So we'll just take and put this right on there like that, push that down, and then we will line up these holes here. So just turn that a little bit, get all that stuff to line up. Take our button screws here. These are just 1032 screws that I picked up from the hardware store, and we'll get these screwed in. Just need to snug those. All the pressure that we're putting on it during the machining process is going down. Okay, so here we've got this all ready to go, and I've got the end mill just above the part surface, and we're gonna run this first cut over. This stuff cuts just real easy. I've already got my digital readouts marked, so I'm just going to take that over my 0. And we'll lock the table down here, and then you can kind of see already we've got there's a hole in there already. We've exposed that. It's the vacuum area, so we're gonna go ahead and we're gonna cut this stuff out of here. It all builds up around the end mill, so you have to cut some of it out and then clear the excess material, so you can see exactly what you're doing there. So we'll get this all exposed. Now we've got that all cut out. You can see this is what you end up with right here, and this is the leftover plastic piece, and we'll just take a pick and we'll pull that out of there, and then this is what you're left with. That's what it looks like underneath that button. There is a small gasket right here that the new button will seat up against. You can see that this is loose. We'll just pull that out of there when we bore this out on the lathe, and there's a tiny little port right here, and this is where the vacuum actually comes from. Underneath, inside this cap, there's a big void around this slide fitting right in here, and as you increase the throttle, it creates a vacuum through this port, which is what lifts that CV pin, that piston, all the way up inside this cap. Really all this plastic does is just provides a soft area for that piston to slam up against when it lifts up, so that you don't have metal against metal and those surfaces beating against each other. So we'll get this out of the milling machine here, and we'll take it over to the lathe. Okay, so we've got our part now with the old button removed, and we have a fixture that I have set up here, and it's held in a 4-jaw chuck, and same way like it was over on the milling machine, except round now. I just got a couple of bolts here holding it in. We're going to bore this out. I've got my boring bar set up. Everything here is ready to go. And really what we want to do, I'm going to try to get as close to this as I can, and hopefully it'll come out for you. But there's a small lip right here. You can see this pick just catch on it right there. And what we need to do is we need to fully eliminate that. And then there's a seat area right here that's under where the gasket went. There's a small step right here, and we have to be aware of that as well. We don't want to remove any material from that and potentially seal off our vacuum port here. Another thing that I should note is that when I set this up, I will have to take a dial indicator, and each individual part I will have to indicate to this bore right here, because there are some concentricity issues on this. The pilot that fits on here and this bore up at the top are not concentric to one another. We'll bore this out, we'll take a measurement, and then we will machine the new buttons that are going to go back in here. We'll get those in, and then we will get this back on the lathe and we'll cut the tops of those buttons so that everything looks very professional and nice when we're all done. And I will show you each step of the process as we go. That was the first one, and so now I will just repeat that 4 times, get all of them to the same point. When I'm all done doing this machining on the lathe, each one of these bores will most likely be a unique dimension, and so we will have to record all of that data on a separate piece of paper and have everything well marked when we machine the buttons. When we make the buttons, we're going to make them 2/1000 larger than this diameter right here. It's called a press fit, and we will warm these up slightly with a small MAP gas torch, and we'll put a little bit of, actually I use super glue, put a little bit of super glue on this surface and on the button itself, warm this slightly, pop the new button in, let everything cool, and it will be as permanent as it can possibly be. Okay, so we got the buttons all out here, everything has been machined. And what we're going to do now is we're going to take a die grinder, and I've got it set up here with some 500 grit emery, some wet dry polishing paper, and we're going to get inside here and we're going to buff all through this bore right here. We're going to get all this, there's all kinds of goobers and stuff down inside there. We're going to get all that stuff out, and that is how this piston slides inside there, and that needs to work absolutely perfectly. So we're going to spend a little bit of time before we put those buttons in, and we're going to buff all this out inside here. Okay, so I've got 2 sets of these piston slides here. The caps are all clean. We've got the machining done inside there. The bore is all cut. You can see that little step where the vacuum is created. There's a port there, and that port comes out right down there at the bottom. You can see that little hole right there. That's where the vacuum port actually comes out and creates the vacuum on the top of this piston here. Okay, you can see these are all gooey too. These are going to need to be clean, and I'm going to stick these in the lathe and do a little bit of polishing. People always think that this is the fit right here, but it's not. It's actually this small diameter right here fitting into this diameter here. And what you want is, you can see if I put these together, see how that just drops. You can kind of turn it. I don't feel any binding. If I had this up in the air here, try to hold it with, you can see how that drops right down. That's what you want to see. This is another one that should do the same thing. This is for the number 4, and we polished the insides, but this is pretty gooey. There's a high spot somewhere, and you test this, put that, see how that does not, even when I drop it under its full weight, it doesn't even come close. I actually have to push it to get it to go all the way down, and if they're doing that, then it's no good. So you're going to want to find out where that high spot is and buff that down until you get this nice. That's the action that you want. Otherwise, you're going to have one carburetor when you let off the throttle. This is going to be really slow to return, and it's also going to be really slow to lift, and you're going to have one cylinder that's running quite a bit different. It's going to give your motorcycle quite a few issues. So you want to make sure that you check all that, and we'll figure out where this is, and I'll throw these in the lathe, clean them up a little bit. We'll do all this polishing, and then I'll show you when we actually start to machine the buttons. Okay, here we are again with the same set of carb tops and pistons, and you can see this is the number 4, this is the number 3, and you can see the difference after I just had this in the lathe and polished it up. I've got these swizzle stick straws on here because I've got the needles still in. I like to not take those out if I can help it, because those screws are in there pretty tight. And they can be kind of a pain, so if at all possible, just be real careful with those. Little swizzle sticks over the top work really well to protect the needle seat. And then I went in here and kind of cleaned that up a little bit, and really this doesn't come into contact, but polish this up. And then I got down inside there, this post right here, the shaft that sticks out is the most important part on this whole deal. And so now when we drop this in, it should work just like it's supposed to. You can see after some buffing, we got that to work just like the other one did before. We don't have any binding anymore. So you want all those to have that nice drop. You want to turn them and make sure that there's no binding anywhere at all, and everything is working exactly like it's supposed to. So I just took, as I showed you earlier, that 500 grit on a die grinder and got in there, and you can see how nice and shiny that is. And just went in there and just polished that all up real good. Make sure that everything is precision clean, surgical clean, so that you don't have any chance of any of that stuff getting down inside there. That'll give you binding, and that's why people complain about these carburetors, because they get that binding in there. But actually, when you get them all nice and clean and you get everything working as it should, they run like a clock, man. They're really nice. So just take your time, do everything, make sure that everything is working exactly as it should. So I'm going to take the rest of these just like this, and I'm going to get them all polished up like that, and then we will move forward and start making the tops. You want to make sure that you have everything nice and clean before you put the tops in, and that way you don't get any of that residual stuff trapped under that top that can give you some issues down the road. So you want to blow everything out, make sure you got everything as clean as you could possibly get it before you seal all that off. Okay, so here we are at the lathe, and we're going to be using some black. This is called Delron. It's a pretty hard grade of plastic, heat resistant. This is what I used in the other caps when I've done this in the past, and it works really good. And I'll show you what we're going to be making here. I've got some dimensions here that I took for the counter bores that are inside the caps. These are the actual dimensions to the 1,000th of an inch, and I am going to be actually machining the buttons to be about 2/1000ths of an inch bigger than this, and then we'll heat up the caps and glue them in. This is the rough dimension that I'm going to make. This is a counter bore that's air cavity. This surface right here will seat against that little boss inside the cap. The piston on the cap will actually come up and strike this section right here when you run the throttle, or when you open the throttle up. And this is just a rough boss that we're going to put on here right now. And after we get all the pieces done and installed, we will machine them in place on the caps, and then we'll be able to come back and cut this surface here, make it perfectly flush, and then we'll finish this off with a little about 45-degree chamfer. We'll just kind of blend that in there, and we'll make this step off right here about 1/8 of an inch. These dimensions here are not critical, really just this diameter, so that you have the correct fit, and ensuring that you've got this pocket in here for the piston to go in against. And this gets cut about 1/8 of an inch deep, and I'll be doing that here on the lathe with an end mill, and we'll make all 4 of them and get it parted off. So I will try to show you guys some of the actual machining process and what it looks like. So this button, you have this cavity, this counter bore in here. It's just the slightest chamfer on this edge right here, and that'll fit down inside there like that. Get pressed in, and we'll do the final machining on that. So I've gone through again, and I have checked that all the slides are going through this bore like they're supposed to, and I've cleaned everything. I just washed that out with some brake parts cleaner, and then I've taken the gasket. Remember that gasket that we took out earlier? It's right here, and I have it just sitting in there. When I part these off, it leaves this nice little stem right there, which makes it pretty easy to hold. So I'll hold it like this, and then while I'm holding it, I will take just my simple bottle of the crazy glue, and I will put it all around the fit surface, which is this large diameter right here. I'll put crazy glue all around that, and then we'll take this when it's warm, and we'll set that right on the top like that, and then we will take our dead blow hammer and we will tap it down into place. You don't want to get too crazy when you tap this in. You just want to make sure that that seats down all the way against that gasket. You can, and I have actually in the past, I have actually crushed these, getting a little too carried away with the hammer, so I was lucky to have an entire spare rack just for parts. It wasn't too big of a deal. So you do want to watch when you're installing these that you don't get a little too carried away with the hammer. So I'm going to go ahead and install all of these, and then we'll be ready for final machining in the lathe. I also wanted to note that when I'm installing these, this is the same fixture that I used in the milling machine, and I just clamp it up here in the vise, and I use the same screws, and that way that keeps this all nice and secure while I'm tapping those buttons into place. I'm not worried. Okay, so we have the caps, the new buttons all installed here. You can see they're all pressed in, and this is what the profile looks like when everything's back in. I have the cap bolted back into the original fixture on the lathe that we used when we bored out the end of the cap for the new button, and I got my turning tool set up here. And so what we're going to do right now is we are going to go ahead and cut this surface right here. Cut this surface right here. We're going to make that flat. We'll actually take just a tiny bit of metal off the top of this so we have a nice smooth transition, and then we'll go ahead and we'll cut the end of this, and we'll maintain that distance is going to be 1/8 of an inch, and we'll turn this small diameter here so that we get all that running good, and then we'll throw a little 45-degree chamfer on there to kind of dress it all up, and then we'll polish it, and that'll be that. So I'll show you guys the final processes on what all that machining looks like. Okay, so now we've got the profile all cut on that. You can see what the chamfer looks like when it's all done. Face looks good, and now we're gonna go on this thing. We're gonna be careful when we're doing this because we got these bolts here, and but we're gonna do the best that we can. We're gonna go ahead and we're gonna polish all the outside of this aluminum with the same 500 grit wet dry paper that we use to buff the bores for the pistons to fit inside. So we're going to slick this up and make it look just a little bit better than it looks right now. And then this is the final product after we've got it all polished up. It doesn't get between the letters too well. It's less than perfect, but it certainly does put a nice sheen on it and makes it look a whole lot better. And we got rid of that nasty old plastic button, and we've got a nice piece of black Delron in there. That sound is what you want to hear. Again, it's tough with one hand here, but you can see that just drops right down in there, bumps up against that plastic. And we just held these things in with, like I said, about a 2 to 3 thousandths press and some super glue, and that'll hold them in there. Remember, you got springs and things fighting these pistons. Don't really hit into that plastic that hard, but that is it from start to finish. So I hope this will help some people out there in the wing world on what to do when those buttons don't work for them. One of many methods that you can use to fix it. So good luck. Thanks for watching.